live up to the expectations. Thanks. I'm hoping you're having a nice day so far in our little town on the Appalachian Trail, despite the occasional rain. I'm Arjen Stolk, as Luke indicated. I direct the Mutual Understanding Lab here at Dartmouth, and the questions we ask ourselves are, how do we understand each other? How can we have meetings and conversations like we're having today, where we reach a shared understanding that we didn't share before? And intuitively, you might think that we can do all this because we speak the same language. And it's true that a common language certainly helps, but we know that people can have quite different associations and connotations with the same words. So the chances we mean the exact same things when we use those words aren't actually that good. Fortunately, there's a solution. The solution is called yo. I hope anyone is familiar with this. If not, yo is the simplest and most efficient communication tool in the world. This is how it works. You have a list of friends. You tap one of the names in that list and a message being sent with a text, yo. Yo is a single tap, zero character communication tool. Yo is everything and anything. It all depends on you, the recipient, and the time of the yo. Want to say good morning? Just yo. Want to say, baby, I'm thinking about you. Yo, come to the meeting, come by my office. Yo. Are you there? Yo. You determine the context. Now, I think it's a bit of a tongue-in-cheek, maybe, this app, but I think it raises a very important question, because how do we determine this context? Right? How do we know what counts as context even? And I think this is one of the most important questions in our field, but I'm biased. But it's probably this ability that allows us to quickly make sense of each other's actions and behaviors, and make sense of the things we say and do in everyday social interactions. It's arguably also this ability that allows us to communicate even without language, or in fact, invent new ones. This is a quote from a granddaughter of a famous linguist, Ray Jackendoff. How do people make up words when there weren't words before? And even human children can do this. In fact, some sign languages were created by deaf children of hearing parents who spoke only a verbal language. So put differently, these children bootstrapped their own communication system without the input from their parents. And these sign languages evolved to become rapidly more complex. Eventually, syntax would emerge, meaning the gestures would combine and form kind of like words in a sentence, a shared structure. More generally, however, we lack a scientific understanding of how humans actually do this. And part of the reason is that research has focused a lot on the product, more so than on the process of communication. For instance, more focus has been given to the properties of our languages than how people can rapidly find relevant context in everyday social interaction. Now, today I will present evidence from an autism study, so no neuroimaging, I'm sorry about that. But an autism study suggesting that a crucial portion of the context is constructed on the fly by the members of the interaction themselves, so by the people themselves. That is, people use behavior not only to transmit information in the information theoretic sense, but they also use those behaviors as a tool to align and shape their concepts of the interaction. And by doing so, they create a shared conceptual space that provides critical context for selecting and interpreting past, present, and future behaviors. So this conceptual space is unique to the situation. In fact, in about 15 minutes from now, we will share a conceptual space that spans previously unconnected concepts like yo, sign languages, autism, and so on. And we'll be able to reference this conceptual space throughout this meeting, but also maybe in the future, on future occasions. Okay, first, let me illustrate why and how we may construct an interaction unique shared context. Consider the following semantically incoherent, but somehow conversationally fluent exchange between a customer and a bartender. A cup of Joe, followed by, we're closing in 5. Add 1 for the missus then. That'll be a $5. I'm sure your brains have probably made sense of this by now, but let me try to sort of disentangle what I think that the customer and bartender needed to do in order to have this conversation. Because cup of Joe obviously is not something you could tell anyone anywhere. So before even saying it, he would need to set up or build a conceptual scaffold of information that presumably approximates the scaffold that's going to be used by the bartender in the current under the current circumstances. And so he might select background knowledge that coffee can be ordered from bars. The bartenders might be familiar with slang words of coffee, like Joe. He might also need to prepare alternative scenarios, like maybe the bartender is actually a cleaner, or that the bar is closing and he cannot order any coffee. So the bartender's reply also functions as a way to tell his partner that he's willing to process and understand that order, even though it might be logically unrelated to a cup of Joe. Now, as the conversation unfolds, the two communicators have to work together to keep their concepts aligned, not with just each other, but also with the current situation, thereby creating this shared context or this shared conceptual space that allows them to select and interpret behaviors that will be more likely to be mutually understood than otherwise. In fact, if the customer is not familiar with the word of fiber, he could consider the shared conceptual space they have at that time, including concepts related to coffee, 2 cups, and payment, and make an inference that fiber refers to $5. And it would be pretty hard to make these inferences otherwise. So I think it's needless to say here that that this ability to align our concepts probably also allows us to invent new words if we need to. Okay, so how can you study this joint construction process? Now, there are a couple of ways. And the way we are pursuing in our lab is to take everyday conversations, strip them of language, gestures, and other social conventions. And the idea being that by doing so, we gain more reliable access to the core, whatever you want to call it, meaning-making process that underlies everyday communication. If you do this, you end up with something that looks like this, the tacit communication game. The goal is quite simple. The 2 players together have to reproduce this spatial configuration on the game board. The problem being that this spatial configuration is only shown to one of the players, which makes the player the communicator on this particular trial, and makes the other player the addressee. Why? Well, the communicator has to produce a behavior that signal to his partner, and she's controlling the orange triangle in this case, that she needs to end up at the top left facing down. He also needs to make sure that by the end of his movement, he ends up at the on the right over here. And then by the end of the trial, if they have reproduced this, success is indicated. Well, let me actually show you this, because that's probably much easier. So first, they're going to see which shape they'll be using. The communicator sees the target configuration. He can plan as long as he likes. Then he moves. She sees those movements in real time, as you saw. Then it's her turn. And feedback is presented. Did anyone see this? Did anyone see what they were doing? Let me quickly show you again. So this is the goal configuration. This is my interpretation. I think he goes to the top left, steps out a few times, what we've come to call a wiggle movement, to indicate, hey, you got to point in this way.
But why does the command back to the original position?
The circle always starts in the center. Yeah, it goes fast, but it always starts in the center or a random location. But in this case, it starts in the center and has to come to a different location. Yeah. It might sound, you might not think, oh, that's easy, but let's try this ourselves. So I switched off the monitor of the communicator in this case. So you're not able to see the target configuration. You're effectively taking the role of the addressee here. Wait a minute. Yeah, here comes. No, I'm not going to give away the answer. Let me pause. What do you think? Where does the triangle need to go? Bottom, center, and then which orientation? Left. Okay. Any other?
Can you play it one more time?
Oh, Mira, you know this already. You can't.
I think top left, something.
Oh. Well, let's see. Okay, let's see. Yeah, you were right. Okay, let's do one more. Wait for it. Here it comes. Any takers?
Yeah.
Like the same?
Yeah. We don't make elaborate. Right.
Facing right.
Well, let's see.
Yeah, right.
Okay.
It's the same. Sorry, I cheated. I showed you 3 trials or 3 target configurations, but from different pairs. So people come up with different solutions for the same problem even. And so I hope it shows you that you need context for this, right? And second, I think also shows us that you don't need any context. You need the right context. You need the one that matters. For instance, it's impossible if somebody steps out, whether this sort of wiggle movement means, hey, I want you to point this way emphatically, or it means like, hey, I want you to rotate as many times as I stepped out, or I want you to rotate as many times as I stepped in, because we've seen all variants. So without context, you just don't know which one it is. I want to show you 3 more movies just to illustrate how dynamic this context really is. What you might notice is that so this is trial 10. These are all 3 from the same pair, 10, 25, and 27. What you might notice is that trial 10 has quite the same target configuration for the receiver or the RC. So you would expect that people do the same thing for these same problems, but let's have a look. Goes to the location, he rotates, which is dysfunctional for his own target orientation. So he rotates back when he gets to his own target. And she interprets this as, okay, I gotta rotate my shape here somehow. Now, let's move to trial 27 first. Same situation, if you will. He's using a rectangle, she's using a triangle. Triangle needs to go in the bottom left facing right. So you would expect him to rotate, but he doesn't. He steps out. Yeah. And she understands this too, she'll see. And the question is, why did this pair abandon their previously successful strategy? Like that just doesn't make any sense from a reinforcement learning perspective, right? You have a problem, you stick to it, you don't change it. Yet here we are, humans do something quite different. In an attempt to make sense of this, I looked at trial 25, just before this one. And I think this might be the onset for the wiggle strategy. It might have been introduced by the fact that the communicator has a circle, and if you rotate the circle, it's not visible on the screen, so it's kind of useless. And this is where he was, I guess, necessitated to introduce a different strategy for a problem. And this worked, as you will see, and the pair decided that it would make more sense for them to continue to generalize this new signal to an old problem, even they already had an existing solution for that problem.
Could people pause slightly between movements to indicate a gap or change it?
That is a great question. Yeah, I don't know. We did a bunch of qualitative analysis, some of which I will show next. But it would be interesting to see if people, use more emphasis in general, like, hey, I'm introducing something new here. Yeah.
Is that optimal strategy?
That's a good question. So this is one of the problems when I explain typically this task. You might think that this is about reaching optimal strategies, and surely optimal strategies are helpful if you have them. But people can quickly change their solution on a dime, really. And so the way people communicate in this game and other tasks is more consistent with not the finding of an optimal strategy, but more converging on what I will argue is a shared space, a conceptual space of meaning and relationships. Yeah, Jeremy. Yeah. Go
Okay,
ahead.
all right. So, yeah, so even if it's not about finding an optimal strategy, you can imagine like, there's a large space of possible actions you could take.
Yep.
And then a subset of them are going to be like effective at communicating, but like,
Yeah.
just moving randomly is not going to convey anything.
Yep.
Do you have a sense of like what that subspace looks like, or?
Yeah, no, this is the question we should ask, I think. So just to clarify a little bit more, yes, there are strategies that are more optimal than others, I would say. But I think what humans are really good at is quickly finding a new solution. That's it. They are really good at finding a new solution based on their recent cumulative experiences together. So there's a bit of an abstract generalization thing going on, I think. I can't really, give a hard answer here, but I'll show you the data from autistic individuals, and then we'll see if the question still holds.
Is the communication like both ways? Like, do they alternate which trial they're using, or like does the planner see what the other person is doing, or?
So they alternate, depending on the setup. Most setups we have them alternate between the communicating and literacy role on trial basis. To promote them to negotiate, we have them face as many new problem types as possible. Not too many, because you have to give them time to converge. But we just like how conversations keep always unfolding contingently on what people have said before. Kind of here we're trying to sort of mimic that by imposing new problems and hopefully see how they deal with it, basically. Yeah. So it's not like let them fix a problem, then have that problem reoccur endlessly. You could, and we have done something like that actually, and you can sort of, get at the neural effects of common ground, for instance. Yeah. Yes.
Are there constraints on how much they can move, or how long they can move for, or how long they can pause for?
So the planning times are unlimited. Good question, by the way. Movement times are fixed. Sometimes we choose 5 seconds, which is sufficient, but for the autism study I'm going to show you next, we did 10 seconds just in case to rule out any motor confounds, for instance, that they.
Like move as many times within that.
Yep.
5 seconds.
You can do whatever you want. Yeah. Yep. Oh, yeah.
Probably we'll get to that, but this paper and like also others that you've had, is like I always wonder like how do you even come up with essentially the space of possible, like how do you analyze the data essentially without going through it and just looking at all the trans? Oh, this is what they did here.
Yeah, I'm not sure if we should bring up the traumas of our students right now. But yeah, there's one sitting behind you who's going to go over a whole bunch soon. So it's great. It's fine.
So that is the strategy.
There's different ways. So this is the first time we're diving in more deeply into behavior and the strategies. Before we have looked more, neural effects. And just to give you, because I'm not showing them today, what our brain data suggests is that actually people don't pay so well. The brain areas that track understanding in this game, because you can measure understanding on an interaction basis, care less about the actual signals. They care more about something way more abstract. And those brain areas track also adjustment in this shared context over time. So we're now focusing on the behaviors to make sense how shared context, determines the meaning of those behaviors. And so, yes, it's a necessity to look at them now. But yeah, we're trying to postpone it as long as possible, of course. Yeah.
So what's the context here? So it's a circular and a rectangular.
Nobody knows what context really entails, right? It's probably very abstract. So this is sort of what we're trying to get at, like what might be the implementation or the process level description of context. Yeah. It's the conversational context, if it helps anything. But then what is part of it? I don't know. It might be the shape movements to some extent, but it might also be what I think we both consider as relevant features in the interaction. Maybe that we both care about certain aspects of the movement, or how it links to other movements that we've made in the past. If you pause a lot, I'd be like, okay, so if I introduce my wiggle, Guangzhou, yeah. I will probably you make sure that I also have my wiggle has a strong pause component if it's relevant for the point. Yes, okay. Does that answer a little bit? The short answer is I don't know myself either. Well, I'm not going to go over this because, but I hope you, well, I would agree with you that superficially this doesn't look at all like everyday conversation. But I hope that you sort of agree that by stripping everyday conversation of these conventions, language, gestures, that we might be tapping in something here. I'm not going to go over all the differences. I'll share the slides afterward in case you're interested. The main thing I want to highlight here is that both settings, everyday conversation, but also this task, allow people to build a idiosyncratic, interaction unique, and dynamically changing conversational context. Okay, how am I doing on time? Sorry, Emily.
How much you got left? We started a little late.
I'm like 10% now.
You go.
No, I must say, 10 minutes. Give me 10 more minutes.
10 more minutes.
Okay, good. Okay. So I hope you realize this is a hard task. Chance level is low. Yeah, people are somehow really good at it. They quickly find mutual understanding despite using these highly unconventional signals. So we wondered if we could learn anything about how people do this by studying individuals who struggle with communication, who are known for communication difficulties, and in this case, individuals with autism. As you may know, autism is behaviorally diagnosed. One of the core diagnostic criteria states persistent deficits in social communication and interaction across multiple contexts. This is, of course, a little bit unspecific. And so in an attempt to explain these deficits, people have ascribed them to various underlying causes, including biases in processing biological and linguistic cues. Others have suggested that the difficulties only pertain to interactions between autistic individuals, but not between, between neurotypical and autistic individuals, but not between autistic individuals themselves because of a different communication style. By the way, these two would predict that autistic individuals do equally well as neurotypicals in our task. Others have suggested that deficits are due to core difficulties with cognitive flexibility or social motivation. Surprisingly, very few studies actually have studied autistic individuals during live interactions, let alone in experimentally controlled settings like the tested communication game. So the data we're showing you today is analyzed by Harshali Waj. She was an undergrad student, did an internship with me at UC Berkeley, and she did most of these analyses. So what we did, we created 3 different pairs. We had full autistic pairs, so 2 individuals diagnosed with autism. We had full typical pairs, and we had a mixed pair type, meaning pairs consisting of 1 individual with autism. This is what we observed. We found that performance drops with more autistic individuals in a pair. And this suggests, of course, that the deficits persist in interactions like these, interactions that are stripped of biological and linguistic cues. It also provides an argument against this double empathy problem argument that it's more about communication style and not about autism itself. Furthermore, we found that the communication impairment was not due to altered motor performance, cognitive flexibility, or social motivation. So what we found was that planning times are matched, movement times are matched, number of moves are matched. The time autistic individuals spend on various portions of the game board is matched. In fact, if I gave you an autistic data set, you would not be able to distinguish it probably from neurotypicals because the behaviors they generate are highly similar to those generated by neurotypical individuals. The variety of signals, as we call them, or strategies, if you will, are matched. Second, autistic individuals were equally inclined to modify their behaviors following a misunderstanding with their partner. And finally, they spontaneously spend longer producing sort of pause behaviors on these target locations of the addressee of their partner to a similar extent as neurotypicals would do. So put differently, autistic subjects are equally motivated to alter the behavior for the benefit of their partner. Yes. Yeah. Yes, good point. Yeah. Yeah, in fact, that allows us to compute one measure, the measure of pairwise alignment. I'll get to that next. So what's going on then? Why is communication in neurotypical individuals so much more successful than you might ask? Well, let's first have a look at how neurotypicals communicate. So I'm going to show you 3 trials, trials 27 through trials 29. And just to preface a little bit, they start here, they arrive at different strategies, but they quickly find each other. And the blue player uses a wiggle to point strategy, and the orange player uses a wiggle to rotate strategy. So it goes there, steps out. I want you to point this way. But she's interpreted as, okay, you stepped out X many times, so I'm going to rotate X many times. So they have a misalignment here. Then it's her turn, so they alternate. Yeah. Twice, 3 times. Doing very slowly too, so I think this might be that, like, hey, here's my cue for you. And he gets it, and you'll see that in the next trial, in fact, he adopts her strategy. And I think the fact that they can use the same strategy on consecutive trials means that they have a similar conceptualization or similar meaning for that trial. Sorry, that behavior. Okay, that's one. Yeah. Okay. Now let's look at the interaction between an autistic pair. So I've got 4 or 5 trials for you here. Trial 34 to 38. Player 2 is actually starts off as a communicator. So it's her turn first. She uses what we call a visit to rotate strategy. So count the number of visits. 1, 2. But he's not interpreting. He's not rotating twice. In fact, he's on different wavelength. He's on an exit line, draw line strategy. You'll see next. This is his strategy. What is she going to do? She is counting the number of visits. Maybe now, let's see. Visits 3 times, meaning rotate 3 times. But he's interpreting it as, okay, I gotta face this way. So still misaligned. Then something happens on trial 37. I'm going to ask you whether you think they now have reached understanding, yes or no. Success. What do you think? No?
That's actually the 2 ways. Brings to the same result.
Yep. Yeah, the 2. Let's see on this trial if they have adapted. She's still using the visit to rotate. And you could probably guess he's still on board with his own pointing direction thing. So it might be a coincidence that the two strategies happen to converge. In fact, this misalignment continues all the way down to trial 44, where so very long, and then a new problem type is introduced. The behavior players come up with new strategies for those problems, yet still misaligned. So the misalignment persists. Just want to highlight that it might look somewhat kind of clumsy from our the luxury of our armchairs, but it's actually really hard, as we know, and I think it's more surprising that neurotypical individuals can actually do this. So to quantify this alignment on the meaning of a behavior between subjects, we or Hashali rated all behaviors and created by each individual. So we had like an alphabet of strategies that we could come up with. In fact, the more you look at this data, the more strategies you will discover. But you have to make a decision at some point. And we consider the pair aligned on a given interaction if the communicator of the trial produced a behavior that was conceptually similar to the preceding behavior or the succeeding behavior when the other player was actually the communicator. So for instance, this player produced A, B, C, B, B, Z. B is the same as this one, so there'll be a 1 here. This B has another B next to it. This D doesn't have any D's next to it, so there's 0. So basically you get a very simple factor of alignment. Allows you to calculate the proportion of alignment. And as hypothesized, alignment predicted success in this task. But more importantly, Hashali also plotted alignment over time. And what you're going to see is that the alignment became, or the misalignment becomes stronger when the behaviors got more context dependent. For instance, you have these circle-circle combinations are fairly easy to communicate. You move to a location, you maybe use more time to emphasize that location. Here, however, as we've seen with a triangle, you have to communicate orientation. People come up with all kinds of behaviors, and all those behaviors can be interpreted quite different ways. So you need way more context to sort of make sense of these types of behaviors than those. 1 second. Using and interpreting these ambiguous signals over here requires shared context. And so to quantify this context, Hashali calculated the alignment between pseudo pairs, who are members taken from different pairs who played the same game, but they didn't share, or they didn't have the opportunity to build a kind of context together. And as you can see, I'm going to plot for you the alignment dynamics from the pseudo pairs, and you can see they closely track those of autistic pairs, right? So this suggests maybe that autistic individuals struggle to deal with the contextual demands of communication, maybe struggle to coordinate a community of context that they can then leverage in succeeding trials. One final analysis, then I wrap up. We also found that neurotypical pairs, unlike autistic pairs, embed their signals in a space, interconnected space of meanings between signals. And so let me unpack that here. Here there are 4 interaction spaces from 4 different pairs. We've got 2 neurotypical pairs on the right. We've got 2 autistic pairs on the left. Each blue trace connects the behaviors produced by player 1 of the pair. The orange line connects the behaviors produced by player 2 of each pair. And what you might see that there are a lot of individual clusters in the autistic interaction spaces. So we have a whole bunch of G's that are only visited by player 2 here, H's, K's, and so largely segregated interaction spaces, if you will, which is very unlike neurotypical pairs who do explore also individual solutions like K over here, H, but they don't really pursue that solution further if they realize that their partner is not able to follow them in that proposal. So it seems that neurotypical pairs continuously monitor their conceptual frame of the interaction, leading to joint rather than individual exploration of the space of possibilities during communication. Okay, let me wrap up. What can we learn from this? Autism, the communication deficits are likely not due to altered motor performance, cognitive flexibility, or social motivation. Rather, it might be that the deficits arise from difficulties in referencing the conceptual frame of the interaction established with a partner. And this would explain, for instance, why the communicative deficits of autism in everyday life often pertain to situations where speaker's intended meaning and then sentence literal meaning strongly diverge, such as in the case of irony or sarcasm. So making sense of non-literal use of words arguably requires a strong grasp of an understanding or of the current context. I hope you also I hope this work also illustrates the feasibility and relevance of using interaction games like ours, and also using autism as a model system for theory development. In fact, if you're interested in more theory, more than I could go into here, I recommend you take a look at a recent book chapter we wrote, Joint Epistemic Engineering, the Neglected Process in Human Communication. As the title kind of hints at, it's written for a philosophical crowd, but yeah, I hope you'll still be able to make sense of it. It also discusses our neural observations. Now, on that note, I'd like to thank you for your alignment.
Maybe we'll do like 1 or 2 questions while Emily is getting set up. And then Arjen, I don't know if you'll be around.
I can be for the break. I have to teach in an hour. So, yeah.
Yeah. So just clone yourself quickly.
Yep.
You can, if anyone needs.
Oh, sorry. Yeah. Sorry. Yeah, you had a question already before. Yeah.
Yeah, sorry.
Yeah.
Essentially, do you see something where the neurotypical partner, so you see that there's like the performance is somewhere in the middle between autism and
Yes.
neurotypicals?
Yeah.
Is that because the neurotypical partner starts to follow the autism participant, and like that they switch into their strategy space?
That's a great question. Don't pin me down this, but I think one of the in our analysis, this has been a while, we also computed the individual measure of pairwise alignment, like individual alignment. And I think that's indeed consistent with what you're suggesting right here, that indeed neurotypical individuals were more likely to adjust their behavior. And so that's probably causing more success still, and also more alignment for the whole pair together when you take that pairwise alignment measure. Yeah. Yeah. But I don't think we reported the data anywhere. Yeah. It was yeah. Oh yeah.
Did you try to decompose decompose factors, like which particular communication that based on individual times, like particularly hard time?
Yeah. We're trying to do that now, actually, in a follow-up study. I won't have the time to go into that, but we're working. We didn't do it for this one. Oops.